Alright, 3-1, transversals. Transversal is a line that intersects a pair of coplanar lines at two different points. So here, I have a transversal. It intersects these two lines at two different points, and it creates all these angles. So we're going to refer back to these angle numbers because there's a bunch of angle pairs that are created when we have two lines cut by a transversal. First of which is called alternate interior angles. Alternate meaning on alternate sides of the transversal, interior meaning inside the two lines. So, two angles that are on the alternate, or you could say opposite, sides of the transversal and inside the two coplanar lines. So for example, 3 and 6, these are alternate interior. Another pair would be 4 and 5. 4 and 5. Okay. Another kind is called alternate exterior. So before we had alternate interior, they were inside these two lines, so you can guess that alternate exterior is on the outside. So here's what it looks like. Two angles that are on the alternate or opposite side of the transversal and outside the two coplanar lines. So 1 and 8, and another pair would be 2 and 7. See how they're on alternate sides of the transversal but outside the two lines. So 7. Okay, let's keep going. I'll have to slide back up to the picture here, but same side interior angles. These are two angles that are on the, you guessed it, same side of the transversal and inside the two coplanar lines. So 3 and 5. So let's take a look up here. 3 and 5 are same side interior, and so are 4 and 6. 4 and 6. Alright, the last one is corresponding angles, and I'll give you the technical definition first. Two angles that are on the same side of the transversal, one on the outside of the two coplanar lines and one on the inside. But the easiest thing that I want you to remember with this is when you see COR for corresponding, I want you to think corner. And I'll show you what I mean by that. Take a look up here. It gives us an example. It says 1 and 5 are corresponding angles. So let's take a look. 1 and 5. Notice 1 and 5 are in the same corner. Top left corner, top left corner. 2 and 6. Same corner. 3 and 7. 4 and 8. Those are all corresponding angles. So, go down here. We can name quite a few. We could say 2 and 6. We could say 3 and 7. And we could say 4 and 8. Okay, let's go to the next page. Alright, so I'm going to just use abbreviations. I'm going to name the first two, and then I want you to try and name the rest. But the trick here is identify which one is the transversal first, because now I have two lines intersecting two lines. So, the first one, 2, 3. 2 and 3. Well, they're both touching M, so that's my transversal, so I'm just going to ignore this going on over here. 2 and 3 look like they are same side of the transversal and inside these two lines. So we would say that they are same side interior, and you could just abbreviate like that if you want. So take a look at 7 and 12. 7, 12. Now we have a new transversal. That transversal is T, and they're on alternate sides of that transversal, and they're inside these two lines that intersects, so they are alternate interior. I'm going to pause the video, let you guys do C, D, E, and F, and see what you come up with. Okay, if you paused the video and did the work, hopefully you saw that 9 and 16 are alternate exterior with N as the transversal. Hopefully you saw that 1 and 14 are also alternate exterior with S as the transversal. 1 and 11 do not share a transversal, so we don't have a name for them, but they're kind of corresponding because this is in the top left corner, that's the top left corner, but they're not sharing a transversal, so we wouldn't actually call them corresponding. But 1 and 9 are corresponding, and 9 and 11 are corresponding. And then 6 and 9 are alternate interior inside the two lines. Okay, let's move on. Now we're going to talk about identifying a transversal. So I'm going to do the first one with you. And there's a little bit of a typo here. This should say C and this should say D. So name the pair of lines for which each line is a transversal. Well, let's take a look at line D here first. Here's line D. And remember, in order to be a transversal, it needs to intersect two lines at two different points. So we have something going on here where some lines are being intersected at the same point. We cannot count those. So D intersects Y and T, but it's at the same point. I'm not going to count those two pairs. But I can count Y and R. So I'm going to say Y and R are a pair of lines for which D is a transversal, and also T and R. Okay, I want you to do line Y, line T, and line R on your own. They might have two pairs that they intersect. They might have one pair. They might have no pairs. So see what you come up with. I'm going to pause the video now, and I'll have the answers up in just a second. Okay, for line Y, we have line Y goes through D and R, right? D and R. And then it also goes through T and R. And so those are both pairs that it's a transversal for. Line T, however, doesn't go through two lines at two different points. It goes through D and Y, but not at two different points. So there's no pairs that it's a transversal for. And line R is a transversal for D and Y, because it intersects both of those lines at two different points. All right, for your summary, I just want you guys to describe what is interior, exterior, alternate, or consecutive. And remember, another word for consecutive is same side. That's just another word for consecutive. Okay, see you guys in the next video.